Okay, today we're going to be talking about some of the math that's involved with our chapter on the pH scale. So you being familiar with these three equations is going to be absolutely essential for you to do well in this chapter. So make sure you have them written down somewhere that's easily accessible to you when you work these problems. This first one, pH plus POH. You've heard about the pH scale before, but POH has more to do with the concentration of the base. So nobody actually knows what the P before pH stands for, but H stands for hydrogen and OH stands for hydroxide. So when you combine the pH of something with the POH of something, the answer will always be 14. So that's really, really important later, and I'm going to post a video about the proof of why that's the case. pH is equal to the negative log of the concentration of hydrogen. That's a lot of information, but really, there's only two variables in this equation. pH is a variable, and the concentration of hydrogen is a variable. So you'll get this number. Normally, it'll say calculate the pH of something that's 0.002 molar. So this unit M refers to concentration. The brackets also indicate on here that this is a concentration that we're talking about. So pH is equal to the negative log of the concentration of hydrogen. POH is equal to the negative log of the concentration of hydroxide. So I'm going to show you what this looks like when we start working these equations. Make sure you have your calculator ready to go for the rest of this video. If you need to pause it and go get it, go do that now because we're going to be working with logarithms and these are a lot easier in your calculator. Okay, so for this first one, 2.6 times 10 to the negative 2 is our concentration of H. So that only leaves us with one thing to be solving for here. I know that I'm using this equation because it tells me that it's the concentration of hydrogen instead of hydroxide. So I know I'm using this equation. Okay, so my pH, that's the thing that I'm finding. It says calculate the pH and POH of these things. So pH equals the negative log of the concentration of hydrogen, which in this case is 2.6 times 10 to the negative 2. And that's all you have to do to solve this. So now to find the pH, all I have to do is type into my calculator negative log of the concentration that I was just given times 10 raised to the negative 2. And that's all I have to put into my calculator. Hit enter. That number that I just solved for is the pH. So the pH of the first one equals 1.5, we're going to round up, 1.59. On pH problems, we're just going to round to 2 past the decimal. So now that I found the pH, that allows me to also find the POH. Since I have pH, and I know that the pH added to the POH has to equal 14, to find the POH, I'm just going to do 14 minus the pH. So 14 minus the answer that we just got is 12.41. So my pH for the first one is 1.59, and my POH is 12.41. Okay, moving on to the next one, it's going to be the same thing. So I'm going to plug this H positive, this hydrogen, into my equation. Again, I'm calculating pH and POH of each of these, but since this problem gives me concentration of hydrogen, this is the first equation that I'm going to use. So I'm going to put pH equal to the negative log of the concentration that I'm given, which is this 1.3 times 10 to the negative 14th. And that gives me an answer for pH, so negative log of 1.3 times 10 raised to the negative 14th. And my answer for that is 13.88, 13.89, depending on how you round that. So my pH is found now. I don't have to do anything else with that. So to find POH, I'm just going to subtract that answer from 14. It should have been 0.89. So I'm going to subtract 13.88 from 14. My POH, by the way, it is possible for these values to be negative if that ever comes up. So my pH is 13.88 and my POH is 0.12. For number 3, this gives us concentration of hydroxide, so that means that I'm actually going to start out using my POH equation. So my negative log, my POH equals the negative log of the concentration times 10 to the negative 2. So negative log of 3.0 times 10 to the negative 2. That gives me 1.52 for my POH. Now to find my pH, all I have to do is subtract that number from 14. So my pH of this is going to be 12.48. Okay, for the last one, I'm going to go one step further on the last one. I'm still going to find pH and POH the way that I've been doing, so nobody freak out yet. But I'm going to take negative log to find my POH. Negative log of 2.7 times 10 to the negative 13th. And my answer for this is 12.57, so that's my POH. To find my pH, I'm going to subtract that number from 14. I get 1.43. Okay, so now that I know that my pH is 1.43, I'm going to go a step further. If you look at the pH scale, on the left side, starting with 1, it's a scale that goes from 1 to 14. So if I start on the left side, these are acids, and closer to 14, these are bases. 7 is neutral. So if I have a pH of 1.43, I'm trying to figure out what that's closest to. So you might have a question that says, is a solution containing this concentration of OH acidic or basic? The answer for this one, since it's 1.43, that's a lot closer to the acidic side of our scale. So this concentration, the answer for number 4, would be the POH is this, the pH is this, and then if I asked you, is it acidic or basic, you would tell me acidic because it's closer to 1 than it is to 7.